So we're working on getting the slide stop working, and we've got some of it coded, but it's not working right yet. So I'm just going to play around for a minute and show you what I'm working on. So we've got this, and we've got it to where this lever is clickable, and if the slide is back, it can travel further up, which is good. And yeah, that time it worked. It works about 1 out of every 20 times, and I don't know why. So that's what we're trying to figure out. So we've got 2 problems. That is that it doesn't always work, but that time it actually did work. So now it's held on that slide catch, which is good. But the other issue is when we pull the slide back and then release it, it should drop that slide catch. It should fall. Because right now the slide catch is being held up by the tension of the slide bonking into it, right? But when you pull back on the slide, it should actually be allowed to fall back down, and then you can snap the slide forward. And I'm going to use a real gun as a prop again, so just to clear it, there's nothing in the magazine, and there's nothing in the chamber. So what we're trying to code right now is, let's lock the slide back. So this is the slide stop on this gun. See that little lever? And that is exactly analogous to this thing right here in the game, right? Different model of gun. This is a high power, that's a Makarov, but it's a similar idea, right? And if we lift it into that little notch on my real one here, right? You can see it's holding the gun slide open. But if I push back on it just a little bit, watch that this lever is going to fall back down when I take the tension off of it, right? See that? And now that lets the slide continue back forward. And that's why you see people do this a lot, right? So let's lock it back. It's locked, right? You could put a mag in it, which we're not going to do. But now if we do this, it releases, and the reason it releases is because you pull it back a little bit, it takes the tension off of that lever, the lever falls out of the way, and then the slide can shoot forward, right? That's not currently working in our game, so we're trying to program that right now. So, and I can show you that. Now what does work is if we pull down on this slide catch, it snaps forward. But so that's problem number 2. Problem number 1 is that rarely works. Pull it back, pull this up, and it snaps just back forward again. So we have a couple problems to fix. I think my logic is just off a little bit, and I have my logic statements in the wrong functions. I think I have them, some of them are in the input methods instead of on the process method, and so it only works if something is in motion, and so it's running my code, if that kind of makes sense. So just silly mistakes, I think, is what I'm making. So let's take a look together here. So on the slide, the first problem is it's not catching when it should. So let's have a look at the code here real quick. And I can minimize my debug window here in OBS. There we go. So this is what happens in the process function for this slide. So it says, am I in battery? Like this gun is right now. The slide is fully forward, right? And if yes, then it just resets the sound effects and nothing happens because it's already fully forward. This is kind of the code that handles like the spring that's returning this guy, right, when we release it. But if it's not fully in battery and the user isn't actively holding it backwards, right, then it's going to snap forward. And so this is the code that does that. So right here, you can see it's going to take the slide's Z position and push it forward. It's going to add to it a certain fixed amount, and we can change that. That's just the speed that we've programmed right here. Right here. So that's all well and good, but now there's a special condition here. there's two conditions right here. So it's saying right here. So just to explain the coordinate system that we're dealing with briefly. Kind of get rid of my scribbles here. Okay. So all of this is taking place to the left of the z origin, right? So the axis that the slide travels in to go backwards and forwards here is in the z direction. So this is moving in the z direction in our game model. And further open is a bigger number. This is a more positive z position for the slide. Closing is a more negative number. That's a smaller number, right? And you can see that from my beautiful little pictures here, right? So negative 48 millimeters is fully closed. The slide is fully closed. So if you think of the center position of the slide, right, a little dot right in the middle of the slide here, right? That is negative 48 millimeters in the z axis. Fully open, so if we draw some ticks, that's fully closed. Fully open, right, is a little closer to the origin, so it's a little bit of a less negative number. That's only negative 15z, if that kind of makes sense. So again, to draw those two dots, if the center was here, that would be the slide closed. If the center is here, as it is in this picture, that's fully open. Make sense? Okay. So, back to the code then. If we've got this. So, my phone is ringing. Telemarketer. Joy, joy. Alright. So, the slide and the slide stop lever are siblings. So, they both have a reference to each other set by the parent. So this is the gun model right here. And when it first initializes, it gives the slide, or the slide stop, a pointer to the slide object, and it gives the slide object a pointer to the slide stop object, right? So those two different items have references to each other, and then they communicate with signals and parameters. So, if we go to the code for the slide, it says, so if it's not being dragged by the player is not holding onto the slide, and the slide is out of battery, the recoil spring is going to want to return the slide to battery. So that's the block of code we're in right here, right? So, it's going to decide what's the furthest it can slide forward. And if the slide stop lever is up, then the furthest it can slide forward, right, is, so it's back here, right? If the slide stop lever is engaged, the furthest it can slide forward is just a little bit. It's just right here. So it can't go down this way, right? It can live over in this little nub over here. And that's kind of analogous to, right, we have the slide stop up, and we can pull it back a little bit, right? But not much. There's just a little sliver of space that it can has a little bit of play at the back there, right? In real life, it's really small, right? We'll maybe exaggerate it a little bit to make our code easier and the game more playable. But in principle, it's the same. So we've got a couple constants set in the code here. So max open is the biggest z value, the least negative z value, right? The closest to 0 that we can get. And then pretty close to that, the held by slide stop value, right, is just to the left of that on the number line, right? So that's this value right here. So this is negative 15 millimeters. This is negative 17 millimeters. And then way over here is the slide all the way in battery, and that's negative 48 millimeters, right? And that's this value right here. So in the process function, right, which runs every time, it's going to say if we're not being dragged by the player, and if we're out of battery, then the return spring is going to try to push us forward. What's the furthest we can go? If the slide stop lever is up, we're restricted to this little space right here, this little window at the very end of the travel. So we've got this variable we're using, this flag, called current minimum z, where minimum means the furthest in this direction it can go, right? So by default, that's going to be all the way over here. That's going to be right here. That's going to be the extreme travel stop in this direction. It's going to be right there. But if the slide stop is engaged, then that will change to be right here. And it can only go that far in the closing direction, right? So far, so good. So now, we go ahead and move it by a chunk, which it moves by 20 millimeters. Oh, I think I figured it out. We need to do the movement after we do the calculation. See, otherwise, it jumps past that point. That's got to be it. See what we're saying? So if we move the slide first, and then we check if it's being held by the slide stop, it's going to jump over. Ah, eureka. That's the problem. See it? See it? It's going to jump past, and then my code's going to check and say, hey, is it going to be held beyond this point? No, it's already moved. Maybe that's the problem. Let's see. Because then what does it do next? Does this. Well, and what might happen then is that might push the slide stop lever out of the way, because the slide stop lever cannot be up unless the slide is all the way back. I think that's what's happening. So let's change this. Let's see if this fixes the issue. Let's put this code in the wrong keyboard. I type in Dvorak for fun, and so let's put this code at the bottom. Alright. And let's see if we get any difference there. Now I'm going to turn on my debug window so we can see what's going on here. Great. Alright. Alright, let's see if that's any better. So we hold it back, we lift the slide stop, and it worked that time. And if I press the debug key, we can see right there. So held by slide stop is true. They are currently touching, and so it's holding that lever up. So that's good. And then slide stop engaged is true, which it is. It's in the that lever is in the up position. See that? Okay, so now it slides forward. Let's try it again. So we hold it back. Now, if we press it up and now we press B, we should see false true, because I haven't released the slide stop. So right now, they're sitting like here. So the lever is up, but the slide is not touching it. See that distinction? So if we go back here and we lift this up, we should see false true. See that? So it's being held by the slide stop. False. The slide stop is engaged is true. Now if we do this, it should be false, false. See the difference? False, false. False, true. See that? Okay. Now if I let go of it, now it should be true, true. That's all working. Okay. Now here's the real kicker. Just got to get that window up high enough so we can see all the logs. Wait for my OBS to catch up. There we go. If I click and drag this backwards, this little lever should be free to fall. I'm using the wrong hand. There we go. Right? That should happen. Let's see if it does. It does not. It does not. And see, it still thinks it's being held by the slide stop when it isn't. So, oh, well, that time it worked. Hang on. That's what we want. Hang on. No. Something's not right. See that? That's kind of weird. Okay. That time it worked. That time it worked. Okay, but now it's falling without us wanting it to fall. See that? Ah. This is just going to be finicky. Okay, there could be a couple things. There could be a couple things. So let's look over here at the slide stop now for a second. So the slide stop checks if the slide is forward. So here's what I'm trying to say. If the slide is closed, right, then this lever cannot really go up much, right? Whereas if the slide is rearward, I'm going to hurt my fingers doing this. Now this thing can move up quite a bit more into that slot. See that? Focus. Ah, well, you get the idea. So, it checks the position of the slide, and it only allows this lever to go all the way up if this... I pointed my finger in the wrong direction. That way. It only lets this lever go all the way up if the slide is fully back. But, I'll show you where that code is, right here. So, slide percentage open is 96% or greater. What if we change that to be down a little bit? What if we give it a little bit wider range? So, I'm saying, let's say this is 0, and this is 100%, right? I'm saying it only allows the user to lift this lever all the way up if this is 96% of the way back or more, right? Maybe that's too strict. And once it settles on that notch, it actually is at 95% open. And so it trips this thing to fall prematurely, and then it's closing itself. See what I'm saying? Maybe that's the parameter we need to tune here, right? So let's just try it this way and see if that was the problem. Let's see if this makes any difference. That worked that time. That worked that time. Okay. Let's do it again. Make sure it's not a fluke. Ah, we hit a error message. Invalid call, non-existent function, quick interact down. Oh, maybe I rolled the scroll wheel. I must have rolled the scroll wheel. Okay. So, let's go to... Because the revolver has a function... So these, every gun has to implement certain functions, right? There's like an interface. You can pull the trigger on it, you can do some quick interaction with the scroll wheel. And on the revolver, that cocks the hammer. And on the semi-automatic, eventually, that will also cock the hammer. Or run the slide or something. We'll decide what we want that to be mapped to. But right now, there isn't that function at all. And so we need to have a function like this. So what happened there is I must have bumped the scroll wheel on the mouse, and that's where we got into trouble. So this should stop that from happening. Again. Alright. Here we go. This is looking better. This is looking good. Okay. That's working as intended. Seems good. Oops. I don't know why those ones didn't work other than I was going too fast and I tried to let go of the slide before this lever was fully up. I think that was what was going on. See that? If I try to rush it, I don't get the lever fully engaged. I think it's working. I think it's working. That's pretty cool. I'm happy with that. That's working as I want it to. See that? Yeah. Yeah. I think that works. Sweet. All right. So I'm going to call that done. And what we need to do next, we solved both of the problems we were having. Yep. Is we need to have the actual hammer do something. Right now it's not doing anything, right? So when we cock the slide back, when we drag the slide back, it should cock the hammer. The one other interesting thing that we could do here is the user should actually feel a little resistance, because let's say I've got this, I'm holding this back with one of my hands. This should be easy to operate, right? Because there's nothing dragging against it. But when it's locked in this position, and again, as an analogy, if we have this like this, right? This now takes quite a bit of force to push down. See that? Whereas right now, it moves freely because there's nothing holding it up. So to simulate that in the game, I think it's going to be really satisfying. When this is locked, it should take a lot further motion on the mouse to get that to snap loose. And yeah, so let's just start with that. Let's keep it simple. So we can do that pretty simply, I think. So if we go here, right? So let's make it aggressive for starters, and let's see how this feels. Make sure it still works. See how easy that is to move right now? But now that it's caught, it should take more of a pull. See how much my mouse moves to get it to travel fully? And now, I don't think I can really tell the difference. Let's exaggerate it even more. Yeah, I can tell the difference now. So it moves freely right now. But then if it's holding the slide open, there's a lot more resistance to get it to unlatch. You have to pull on it hard to get it to come off. The other thing we could do is we could have it related to the speed. So if you're not moving it, so we could actually change this to be a little, we can just play around with how this feels. We could change this to be a little bit less aggressive. But if you're moving it under a certain speed, it just doesn't move, right? So first of all, we're going to have to see what those speed numbers are. So let's just check it. Like this, right? So the fastest we moved it just there was 0.4 or 0.7. The slowest, or 1.9 even. The slowest we moved it was like 0.1. Okay, so as an example, is less than 0.4, let's say, 0.5. See how that feels. Right? So we latch it backwards. That works. And then you want to pull it down. But if you try to pull it down slowly, nothing happens. Well, nothing happens, period, though. So let's see. Let's make this a little bit less aggressive. No, that's still way too high. All right. All right. Oh, I'm still printing those numbers. Oops. Yeah, she's not moving. Okay, we've messed something up here. Okay. Wasn't those our numbers though? Like on the debug log over here, you can see 0.3, 0.1. You would think that would be working. If percent travel is less than 0.01, percent travel equals 0. It's before we apply the multiplier. Oh, it's negative. Okay. Duh. Okay, easy. Easy. So let's go back up, because see these numbers? These numbers are actually pretty big. So let's go back to 05. Or 04, maybe. Okay. I like that. So if you try to pull it too slowly, it's not going to do anything. It makes it feel sticky. It makes it feel like it's really stuck on there, which is true to how it feels in real life, right? I've got this back. When I try to push on this, and I just push on it lightly, it doesn't do anything, right? I have to give it a good solid push for it to snap free. Right? So. And we can experiment with this a little bit. So we could keep this actually pretty high. Let's keep that at 1 for a second, and then let's increase this to like 2 or something, or 1.3, sure. See how that fat feels. Alright, so let's lock it back, right, and then try to pull it down. So if I just pull it slowly like this, nothing happens. I have to pull it down with a little bit of authority. I like that. I think that's the way to do it. So we can get rid of this multiplier. Just keep it simple. And we could change this number around, but I like that just fine, so that seems good. Alright. That's enough boring for one shot, but that's that bit done. So the next bit is we want to make the hammer work when you do the slide. And we're going to have a similar kind of mechanic where, because let me tell you, right, if we drop the hammer on this, which requires a magazine in there, so I'm going to put a unloaded mag in here, and lower the hammer carefully. Okay, there we go. This gun has a magazine disconnect, so we cannot lower the hammer without a magazine in there, but now the magazine is back out. See, that hammer's back, right? If I try to pull the slide back like this, it takes a lot of effort. But now that it's cocked back, it's much easier. And the reason for that is, do it again. You're fighting both the recoil spring and the hammer spring, right? So if I cock the hammer first, right, like this, it takes a little bit of force. Now, you're not fighting that when you try to run the action like that. So, we can represent that in kind of the same way we just did, by having a threshold of motion on your mouse where it won't move it at all. Or have a multiplier where you have to move your mouse a lot further to get it to actually go anywhere. It's going to be a lot harder to pull it back if the hammer isn't cocked. That sort of thing. Anyway, next time.